Good morning, everyone. Hope all of you are staying healthy and happy. My name is Sonia Prasha, and I'm representing the Indo-German Chamber of Commerce. And it is my honor and privilege to welcome all of you, ladies and gentlemen, to today's morning session, indeed a very special session under the webinar series which the Chamber has been organizing for the last 3 months. Our presenters and partners for today morning is Testo India. Testo India is an esteemed member of the Indo-German Chamber of Commerce and also a very impressive representative of the German industry active in India. So welcome Testo India, our partners for today morning. Testo India is a 100% subsidiary of Testo Germany, which is a world leader in design, development, and manufacturing of electronic portable test and measuring instruments, and is actually backed like typical German companies with huge number of years of experience, that is 60 years of experience of measurement engineering experience. They are market leaders, and they are market leaders in this sector, and they take everything which is concerned with the product very, very seriously, whether it is service, support, and availability. They also provide the best suited product for wide range of segments like HVAC, power, steel, railways, food, pharma, energy, and many more. Testo thermal imagers play a very crucial role in thermal scanning of people to detect elevated body temperature. And that brings us to the topic of today morning, and indeed a very special topic in these very special times. Thermal scanning in workplaces, a must in COVID-19 scenario. I'm eagerly looking forward to hearing today to Testo India's presentation. In these times, ladies and gentlemen, when we all continue to fight against the pandemic like COVID-19, preventive measures, of course, are the best tools to defeat the threat. The facility managers of corporate offices, industries, large organizations, they carry a special responsibility for prevention and to ensure public health in their companies. Mass scanning of people via thermal inspection, IR temperature measurement, and fever detection plays a crucial role in this aspect. Now, with the government mandates which have been laid over, and stressing the necessity of thermal screening and temperature measurement in organizations, this webinar from Testo India is indeed very useful. Our presenter today morning from Testo India is Mr. Parag Yelegaonkar. Mr. Yelegaonkar has an engineering background in electrical stream and also holds integrated management degree from XLRI Jamshedpur. With a very vast industrial experience for more than 30 years, Mr. Parag has actually devoted 17 years as industrial automation professional and 13 years in business development and project sales. He's been associated with Testo India for more than 5 years, and he's been mainly working with PSUs like Power Grid, Indian Rail, Metro Rail, transmission, distribution, and generation utilities. Also renowned medical research institutes. Mr. Yelegaonkar has actually introduced several advanced T&M techniques in railways, pollution control boards, and power plants. He is an active member of ASNT, American Society for Non-Destructive Testing, and is certified level 3 thermographer from Infraspection Institute, USA. In the current scenario of COVID-19, Mr. Yelegaonkar is dedicated to impart knowledge about importance of mass thermal scanning and educate facility managers and other professionals about the application of infrared cameras for fever detection. Some of his important medical research projects are at AIIMS, New Delhi, NIMHANS, Bangalore, LTPGI, Lucknow, and RR Referrals Military Hospital, New Delhi. Mr. Yelegaonkar, honored to welcome you today, and we're very happy that Testo came up with this idea of holding this webinar for our industry, for our members, and we are very, very happy to welcome you today. Over to you, Mr. Yelegaonkar, stressing upon the topic thermal scanning in workplaces, a must in COVID-19 scenario. Over to you, Mr. Yelegaonkar.
Thank you all. Thank you, Sonia, for this brief introduction of mine and Testo. And I welcome all participants. Very warm welcome and good morning to all of you. And thank you for sparing your valuable time in attending this webinar on topic thermal scanning at workplaces under this COVID-19 scenario. So let us begin directly to our webinar topics today. I just would like to brief you about Testo. Testo is a German MNC, and we are headquartered at Lenskis and TTZ. Our headquarters is at TTZ. This is a new building for headquarters, Testo Germany. And Testo Germany has 33 subsidiaries in 25 countries, and we have 80 sales and service partners spread all across the world. And we have 3 sites in Germany, Lenskis, TTZ, and we also have Kinsgarten. And in Berlin, we have our development center. The Testo Management Board, Mr. Burkhard Konaspe is our chairman, and we have other colleagues like Eckhart Cloth. Then we have Peter Krauschel and Merwald. Yeah, Testo has got a global presence. We have very stable and robust growth, and we are now touching to 350 million euro. We have very strong R&D, and we spend almost 10% of our investment in R&D, and we have 200 plus developers at Lenskis, TTC, and Berlin facility. Our main focus is to develop high-tech sensors for various industries, and we have also developed various kinds of apps in current IoT and IIoT scenario, and we also do have cloud solutions. Testo is having 3 major verticals. Instrumentation is the major vertical, where we have test and measuring instruments for various industries and sectors. Then we have upcoming vertical, that solution business for pharma and food. And we have services under that. We service our instruments and we calibrate our instruments at Germany. And we also do have local calibration center at Pune, which is enable accredited. So this is Testo India, where we have sales, marketing, service, and calibration center. Now, as regards to the Testo broader level, the product basket, we have gas and particle instruments, we have portable systems, we have thermal imaging cameras and transmitters, and we have service and calibration centers. So today our topic is thermal imaging cameras. Now today's agenda, I'm going to cover thermal scanning, an essential tool during this COVID-19 epidemics. And we also had faced H1N1 and Ebola like that. So I will touch upon basics of infrared science, understanding body thermal regulation under the fever conditions. Then we have modes of contact, non-contact measurements, so NCIT, that is thermometer and infrared thermographic camera. Facts about the few thermal scanners in the market. Currently, there are a lot of misconception in the market if you see in the social media and through various networks. So we will also touch upon and make you aware on that. Then what thermal imaging can do and what cannot under such epidemics for this fever detection is concerned. Then how resolution and thermal sensitivity of a thermal scanning cameras affects the measurement accuracy of the thermal imaging cameras and scanners. Then there is a debate, actually, what is more accurate, the eye or the ear, and what is convenient, That also we are going to look. That is also a very important topic today. And then I'm going to take you through our Testo model 890, which is a semi-stationary solution for fever detection at workplaces and public places. And there is also another model, which is model 872, and how we can do the fever detection with the help of these models that currently we are offering in the market. So we'll start directly with the thermal scanning and epidemic tool during epidemics. Yeah, see, since we all have been facing this coronavirus since January. It started in December 2019 from China, Wuhan city, and now it is spreading all across the world. And India is also worse affected nowadays. So since there is no vaccine for coronavirus, and it is still month and a year far away from creation, as well as once it is created, then mass distribution is also we need to look into. The only way the virus does not become worldwide community and spread as community level with a higher level of severity, we can limit the exposure and spread of this airborne disease with the latest technologies like thermal scanners and to detect the febrile persons, and when it is used adjunctively with the other methods of detection. And this is the way we can stop the spread of coronavirus. Now the blessing is we have the system for prevention, since there is no cure or there is no vaccine as yet. Now if you see the pandemic curve, so this is the pandemic curve. The outbreak, it is started, and the time since outbreak. This is the baseline, where the health care system capacity is there. And if we are going to take a protective measure, preventive measures, then this is the curve which is observed. Okay, so you can see here, if you take the proper measures, protective measures and safety measures, so we will be well within this healthcare system capacity, which is available on an average basis all across the world. Yeah, so just a technological diagnostic curves, we can see what is that. So we all, most of us are all engineers, and we do troubleshooting most of the time. Okay, so if you rescue, if you rescue an aircraft whose engine is failed during the flight, you will become a hero. Okay, but if you rescue an average aircraft per month, or average machine, you can say, in case of the industries, then no one probably will thank you. So on the contrary, you will be considered as a troublemaker. So most of the colleagues from various industries works in technical services, engineering departments, maintenance department. They must have experienced this, right? So as till date, India is also considered as successful because we had started the lockdown very early, and we have avoided our situation like USA, Italy, France, like situation, since the government deployed this lockdown, and we are not that way, worst under this worst condition like United States. So the application of restrictions we did very early, so that is led us to the prevention of this COVID-19 at larger level, community level actually. So and the mortality rate is also less than the countries like USA, Brazil, and some of the European countries like Italy and France. Is paradoxically used as the strongest argument. This is nothing happens. Okay, so that was the sense. Now, if you see, the infrared body surface temperature screening instruments are widely used under these various epidemics. If you see, starting from 2003, it was SARS, 2009, H1N1, 2012, influenza, then Ebola, and then mouse epidemic in Inner Mongolia, and 2019 we started facing the problem of COVID-19. Yeah, and the government authorities should be very proactive under this condition. So now it is a high time we should be proactive the way it can, and IR, that is infrared, can be very, very useful and important tool if you know what we are doing. And however, if you are determined to use the technology, the latest technology available, and with no testing and without right kind of product suitable for this application, then we expect we will not do well. So we need to consider that the product should be with the right technology. The manufacturer, the supplier should have good amount of experience in this. Then the capability to extend the training, then impart the knowledge on this, and testing we should have. So that is the way we can take the preventive measures to detect the people with higher body temperature, escalated body temperatures. So it is a non-invasive and non-contact technology for febrile person detection. Yeah, see, you must understand that I'm not a medical professional. I'm engineer by trade. So whatever some medical terms which I'm going to explain you, those are best with the guidance from various medical experts and through various publications. So as per the medical experts, an infected individual can spread this disease to others, those who are coming in contact, before having a symptoms like cough, cold, and fever, or shortness in breath. Now, once the fever is ensued in an infected individual, the virus is much more active and it can spread more fast and it will be more contagious. That's what, as per the medical experts. Yeah, as far as the government of India is concerned, Ministry of Home Affairs, they have issued a notification. It is in the first week of May. And if you see the clause number 12, it is mandatory to provide the thermal scanning at workplaces in addition to hand wash, sanitizers, and the other mechanisms that we are following. Okay, so thermal scanning is one of the important tool at workplaces and all at public places to stop the spread of this contagious disease. Now, we will start with some basics of infrared science because there are most of the participants, they are from various streams, various backgrounds. So we quickly see the basics of infrared science. Yeah. Now all the bodies, those are warmer than the absolute temperature, that is minus 273.15 degrees C, emits the radiations. So the emitted radiations are seen by the infrared detector through the infrared lens or optics, and then the radiation signal is converted into the heat signal, and the thermal image is produced over the display on the thermal imager. So this is how the thermal imager works. Yes. Now we all do for such applications a passive thermography. So the band is the electromagnetic radiation, the electromagnetic spectrum band under which we are operating is 7.5 micron to 14 micron. So this is the band where we use the thermal imaging cameras for various applications like electrical, mechanical, medical applications, and mostly we operate in long wave, that is 7.5 micron to 14 micron. We need to also understand some important parameters as far as thermovision scanners and cameras are concerned. One of the important parameters is infrared resolution. So if you see this particular image with 160 by 120 infrared pixel camera, and this image is with 320 into 240 pixel camera, infrared pixel camera. So you can see the difference. So as we progress, you will understand the importance of having the better resolution camera and some of the better thermal sensitivity also. So this is one of the important aspect of thermovision camera and scanner, that is thermal sensitivity. It is very, very important for fever detection application. So what is thermal sensitivity? Thermal sensitivity is nothing but the capability of a camera to identify minimum temperature difference between any two pixels. So I showed you in earlier slide the pixels. One was 160, 120, and another was 320, 240 pixel camera. So the minimum detectable temperature difference between any two pixel. So you can see here the image with 80 millikelvin NETD, that is thermal sensitivity camera, and 50 millikelvin. So here you can see the minute temperature difference also can be identified. So lesser the NETD, lesser the thermal sensitivity, better is the camera. So you can find out a smallest change in difference between any two pixel. So that is what is recommended for fever applications. Now, when we talk about any infrared instrument, irrespective of it is a infrared thermometer or thermal imaging camera, three important aspects you need to consider and understand. One is the emissivity, reflectivity, and transmittivity. These are the three important parameters. And out of three, emissivity and reflectivity plays very important role while inputting the parameters. What is emissivity? Emissivity is a measure of ability of any material or any object to emit or to give off the radiations, infrared radiations. It is also called as electromagnetic radiations. And the reflectivity is a measure of ability of any material to reflect the infrared radiations. So these are two important parameters which we need to input in the instrument. Another aspect is transmittivity. Transmittivity is the ability of a material to allow or to pass through the infrared radiations. Most of the material are not permeable, so we don't have to worry on this. Any infrared instrument can see the surface, not within. Another important parameter one must understand while doing any thermography work is a field of view. So how much your lens can see is dependent on this particular parameter, field of view. Generally, it is given in degrees. This is horizontal degree, and this is first is horizontal, second one is a vertical degree. So this is the field of view. So it can be selected as per the applications. So whether you are doing the thermography application in medical field, fever field, or any electrical, mechanical areas. And another is aspect or parameter is IFOV, that is instantaneous field of view. So here, what do you mean by instantaneous field of view, IFOV? IFOV is minimum detectable target size. And this is a geometrical IFOV and measure IFOV. IFOV measure, that is, you can measure the temperature, that is equal to IFOV geometric into 3. Generally, it is given in milliradians. So it is like that if you hold a camera and from the object at 1 meter distance, if you have 3.4 milliradian camera, that means you can find out the minimum object size of 3.4 millimeter from 1 meter distance for a camera having IFOV equal to 3.4 milliradian. So that is how is the explanation for IFOV. Yes, when you talk on any infrared instruments, whether it is IR thermometer or camera, we need to understand the basic theory, that is conduction, convection, and radiation. So what is conduction? Conduction is a heat transfer that happens through or between any solids. Convection, it takes place via the fluid, and the radiation, the heat transfer via radiation is with via varying electromagnetic wavelengths. And we have seen the wavelength in which all these thermal imaging cameras under passive thermography, they are operating, that is between 7.5 micron to 14 micron. So this small picture will explain you these three important parameters and definition about the infrared. Yes. Now we need to understand our body thermal regulation under the fever conditions. A human body is endothermic. So what is endothermic? it is a capability to generate their own heat, body heat via various means. So how our body generates the heat? So when we do the exercise, when we eat food, then our body generates heat internally. So that is called the endothermic. Our body is endothermic. And endotherms, that is human being, use our metabolism rate to regulate our own body temperatures and to maintain it at an optimum level, or you can call it as a balance level. So this is nothing but the thermal regulation or thermoregulation of a human body. Now, when we apply radiation, conduction, and convection to the human body, so how it is, so we will see. So radiation, as far as the human body is concerned, it is a loss of heat from the body in the form of infrared rays. Our body lose the heat. And conduction, so whenever we sit on the chair, whenever we go onto the bed, so our body heat is transferred to that particular object where the object which is coming in contact with our body. And convection, that is, see, whenever you are sitting in a room where fan is running or air conditioner is running, then our body heat is lost through the air currents surrounding our body. And another important aspect is the evaporation. So we lose the heat because of the process of evaporation. That is, you normally observe when the body sweats. So when the body sweats, our surface temperature, skin surface temperature goes little bit down. So because you are giving away the heat. Okay, so this is happening in the evaporation method. Now, normal temperature regulation, how the body regulates, how the body balance out the temperature. So normally heat is continuously produced, as we seen that we generate the heat internally, and then it has to be lost to make the body as a balance. So rate of heat of production, so whatever heat we are generating by exercise and by eating, that should be equal to the heat loss. And in this condition, if your rate of production is equivalent to rate of heat loss, then you are called as your body is perfectly heat balanced. Now, when there is a disturbance, something goes wrong as far as the rate of production is concerned or loss is concerned, then you are going to lose the equilibrium. You are going to lose the balance. So between the two, then the body temperature may rise or may fall. And if the body temperature goes up, then it is a febrile condition. And if your body temperature falls, then it is called as a hypothermia. This is how under various climatic condition, our body temperature profile, thermal profile looks like. So you can see the temperatures right from bottom to top, how it varies. The body surface temperature on the forehead differs from the internal body temperature, so which is generally taken orally and rectally by a medical thermometer. Our human body normal temperature for healthy human being, it is generally between 36.5 to 37. Okay, so when we are at a various temperature levels, irrespective of you are in the air conditioner, whether you are out under the sun, so the normal human body temperature is generally between these two values, 36.5 to 37 degrees C. Now, what are the methods available for temperature checking? So we have rectal, oral, and auxiliary. So in rectal, the doctors use a rectal thermometer. It is a contact type. So that is the most accurate when a medical health professional or a doctor has to declare a person as febrile person. So this is the final check they do. Or sometimes they use underarm and mouth using a liquid thermometer. You must have experience in old days. So today also some people are using liquid thermometers, and they use underarm and in the mouth to find out the core body temperature. Yes, under the epidemics, it is not possible to use both these technologies, both these tools, because we should not come into contact with a person having a viral fever or corona or Ebola or H1N1. So that time, people started using the infrared thermometers and thermal vision cameras. So infrared thermometer, as far as infrared thermometers are concerned, those thermometers we project onto the forehead and ear canal to see the body temperatures. So what are the modes available? So there are non-contact, two modes are available, which is NCIT and IRT. NCIT is non-contact infrared thermometer, and IRT is infrared thermographic camera or scanner. Now we will see what is the difference. How does the thermal imaging system, cameras or scanner differ from a thermometer? So both the thermal imaging systems are non-contact and non-invasive. Okay, so both are same. And here we measure the temperature without any contact. A non-contact infrared thermometer measures surface temperature in a single location. So when you project a non-contact thermometer, it measures a single point temperature. But in case of thermal imaging cameras, we are measuring the temperature differences across a multiple location on the human body or on any object. Okay, so creating a relative temperature map of a object or a human body or a face. Now we see first the non-contact IR thermometers. So infrared temperature measurement instruments that allows non-contact measurements on the body surface, where the temperature is normally measured on the forehead between the eyebrows and the hairline. So the value here, the point here, if you can see, here the maximum energy is radiated at this particular point, and whatever radiated energy is absorbed by the infrared detector in the infrared instruments, infrared thermometers, and then the radiations are converted into a temperature signal. Now, as far as non-contact body temperatures are concerned, for screening various people, you need to have certain protocol. We need to follow certain protocols for infrared thermometer as well as for infrared thermal imaging cameras. Generally, our human skin emissivity is 0.98. And when we do the measurement, we need to consider that the person and the instrument both has to be acclimatized with the environment where you are going to carry out the temperature checks. So that is an important aspects. And another point is you need to measure the temperature from body, forehead, and to instrument. Generally the distance should be 5 centimeters. So you have to be 5 centimeters away from the forehead or a ear canal. So emissivity sometimes can vary depending upon the subject that is the skin type, whether it is oily skin, dry skin, and the site conditions, under which site conditions you are operating. So it is dependent on that. Generally it is 0.98. So Testo offers Testo model 835 for the measurement of single point temperature, that is infrared thermometers for forehead and ear canal temperature measurements. So what is more accurate? As we progress, we will see this is another model, Testo model 830. So these two models we are offering currently in the market as a very basic tool for a very small applications, very small segments. So now this is very important topic we must understand. So currently in the market, there are various misconceptions. If you see on the Google or on the social media, there are many companies. I will not say the companies, where are they from? You are very much aware. They are, uploading their various videos, various data sheets, and hype in the market as far as these thermal scanners are concerned under this COVID-19 situation. So we will see. Okay, so different videos you must have seen on the media, social media, and on Google. So now this is a video stream from one of the manufacturer. If you see here, the green rectangle and squares, and above that you can see the temperatures. Now, how does this function? How does they arrive at it reading? Here you can see, besides that, the person, if you see, wearing a hat, goggle, or muffler, and still the temperature reading is displayed over here. And they say they use a lot of algorithms and various kind of technologies, and they display the temperature. So you need to understand at sometimes the algorithm doesn't work. You need to understand the basic science, the basic technology of measurement. So how that is going to affect the reading, we are going to see in the coming slides. So here you can see the pointer is randomly shown over here. So what does it mean? So the maximum temperature is checked. It is very hard to say which temperature it is checking and before it arrives at displaying these kind of temperatures. Yeah, you can see here person wearing the hat, mask and goggle, still you get the temperature under this various algorithms. Okay, so there are two people here wearing glasses which are not suitable for marketing presentation due to the requirement of IEC. IEC 8061 601 says something different for measurements. So we will see what is specified. So IEC 80601-2-59 standard can create an impression on the people wearing the glasses, can also be measured. So for the figure, if you see on the back here on the right, the entire face is almost covered. And if the temperature in the rectangle is obtained by averaging or a mean value before it displays, the apparent lower temperature on the glasses is likely to be included and can add to the error. Okay, and again the Indo-German Chamber of Commerce recommends the apparent lower temperature on the glasses is likely to be included and can add to the error. Okay, and again the emissivity is also a matter. The face detection function does not change in the above. Now, the conclusion, you have seen these two slides. You must have seen similar thing on the media. So the conclusion or the takeaway with such system is not to prefer unless we know, unless we get convinced ourselves what exactly how the measurements are taking place. What is the technology, before they design such algorithms. So our aim should be minimizing number of false positive and false negative cases and improve the efficiency of screening. Now, what is false positive and what is false negative? Now, false positive, I'll just give you an example. Person, after doing an exercise, the body temperature increases. Person eating too much of food, the body temperature increases. Okay, so that can be a false positive case. But as far as these cases are concerned, false positive is not dangerous because person may be declared as in a false positive temperature, more temperature because of these two regions, and then further the investigations are carried out. But the false negative is more dangerous. So how the false negative case can happen? If a person having fever because of maybe a viral fever, the fever could be because of corona or Ebola or H1N1. If the person comes from very high humid atmosphere or a person coming from non-ventilated areas and the person having higher sweating, that time what happens, his or her body temperature reduces, and then with the help of IR thermometers and scanners, the person's temperature is shown less. So that can be a negative case. So we should avoid such negative cases by following strict protocol of measurements. So false negatives are always dangerous and catastrophic. So this is how testothermal imaging cameras are tested under various extreme conditions with the help of black body calibrations. So, whenever we use the thermovision camera for such kind of measurements under COVID-19 or under all similar epidemic conditions, we need to understand what it can do and what it cannot. The thermal vision camera can only detect, measure, and document the variations of skin surface temperatures. What it cannot detect is if somebody is sick or healthy, if somebody has any kind of infections, and if somebody is contagious or not, it cannot detect. So diagnostic decisions can only be taken by doctors, medical health professionals using their fever thermometers on the people detected with escalated body temperatures with the help of thermovision cameras. So this is about can do and cannot as far as thermovision cameras are concerned. Now we see the benefit of having better resolution and better sensitivity. As I explained you in the basics, how it affects, we will see now. Now we have taken two images. Now image on the left is taken by 320-240 pixel infrared camera. If you see the Testo model 872, which is having this pixel size and the thermal sensitivity of 60 millikelvin, that is 0.06 degrees C. And this image is taken by 160 into 120 infrared pixel camera, that is Testo 868, having thermal sensitivity of 100 millikelvin. And here we have done some experiments by taking the temperature in the eye corner, which is the highest temperature, and on the selected area of the forehead in both the cases. And you can see the image quality in both the cases and the temperature reading with higher resolution camera. It is closer or near to the core body temperatures. You can see temperature in the eyes and in the on the forehead. You can see the temperature differences. So here the temperature is little less with a less infrared pixel camera. And here it is more clear and near to the core body temperature. In case of Testo, we have super resolution technology, and with super resolution technology, the image quality gets enhanced and image total number of pixels also enhances 4 times. So you can see the image without super resolution technology and with super resolution technology. So you are going to get benefited in terms of measurement also. So here you can see with the super resolution technology, the image quality and the measurement also improves. So this is a default feature with Testo thermovision cameras. You have to just enable it, and it is free of cost available in Testo thermovision cameras. Now we see there is a debate currently in this particular area when we talk this subject of fever detection. What is more accurate, whether it is the eye or ear, and what is more convenient as far as thermovision scanning measurement point of view, and that is also equally important. So we see what is more accurate, eye and ear, and you will be able to see and conclude what is more accurate after you see few slides now. So the fever detection by thermovision camera or scanners. So any thermal camera for the said purpose, when it is used for fever detection, we are monitoring the escalated body temperature, and it is a relative temperature measurement, not the absolute core body temperature measurements. So the thermal imagers will give the hottest point within the field of view, or if you select a region of interest. So if your region of interest is the eye or ear, so it gives the hottest point. So generally, eye retina, or we also call it as the inner canthus of eye, that is corner of eye where upper and lower eyelids meet. That is a sensitive point where all the energies are concentrated and emitted. So temperature here is near to the core body temperature, not exactly, but near to the core body temperature. Now we will see. Now if somebody has a fever condition, maybe equal to or more than 99.5, further medical investigations are carried out. If this temperature has been detected by thermovision scanner or similar technologies, then one must go to the doctor or medical health professional to find out with their medical grade IR thermometer, contact thermometers, or ear IR thermometer as to what is his core body temperature, and then the doctor gives further treatment. Yes, now we see exactly the eye tear duct and ear canal. What is the correlation between two? I'm just showing you the same thermal image of a same person here, and here we are measuring the eye temperature. That is, this is the point where we are automatically getting the temperature by selecting this region of interest in thermal camera. And you can see here the tear duct 34.5 and 34.9. And when we take in the ear, it is just slightly higher, that is 35.6, not great difference. Yes. Now, in a ear, there is a tympanic membrane. So tympanic membrane is a very, very important organ in our body, which gives the core body temperature. So from thermal imaging camera standpoint, scanning tear duct is very, very convenient and easy rather than scanning the canal and accessing the tympanic membrane. So additionally, to access ear canal, you have to often use a contact thermometer to reach ear to the tympanic membrane temperature. So if you use this, the contact type thermometer in ear, then there is a transmission risk under such epidemics. So hence, thermovision scanning standpoint, it is most reliable to see the tear duct, to see the temperature in the tear duct, which is not too far away from the ear canal temperature. So there are few examples with few different infrared pixel cameras. You can see here the eyes temperature and the ear canal temperature. The difference is not great. So the most convenient is to see the temperature in the tear duct. And for your information, that tear duct is connected with a vein or to the brain. So you can see with 320 to 40 pixel camera, and with high-end 640 480 pixel camera is still more accurate, more clear. You can see the difference in image quality and the reading. So you can see the ear canal and the eye is almost equal. And you can also see the forehead also. And why forehead is generally not recommended for thermovision scanning standpoint, we will see. Now there is a lot of research has happened whether eye, ear, and forehead. So there is a linear regression method which was followed to determine this which one is accurate. So if you see the regression model, it is a simple regression model which was followed to do the research on this. So in this regression model, there are dependent and independent variables. So under the dependent variable, we see the skin surface temperature values by thermal imager, and under independent variable, we see the ear by clinical thermometer. So that is independent. Now, from this regression analysis, it is known that the particular area on the skin surface that it will produce the most consistent the most consistent results it can give concerning to the core body temperature is the area in the eye, that is the inner canthus. So this model is regression model is used to do the research and to arrive at temperature measurements in the eye, and then it is concluded that it is convenient and easily accessible point is tear duct, which gives the near to core body temperature. Now you see here we have take another image. You can see here we have displayed over here the ear temperature of a febrile person, 39.1. This is the point, and at the same time we also have seen the difference on the skin temperature. So here you can see the skin temperature. So at somewhere 37 and 38. So normally our skin is exposed, and as I told you, the emissivities and the surrounding conditions and the body conditions, sweating and other thing, because of that the surface skin temperature differs, but this gives the more accurate temperature ear canal. And then as I told you, ear canal and the tear duct are almost same. So according to the technical standard ISIS 80601, it is the area, that is this area in the media adjacent to the inner corner of eye, that is excellent for fever screening. This is due to the stability and sensitivity of this particular area, where this is located directly above the passing carotid artery, so that is connected to the brain. Okay, so that is why this is the critical point and important point as far as the measurements are concerned. So you must have understood now the debate about ear or surface forehead or tear duct from the scanning standpoint of view. So it is concluded that from the scanning standpoint, thermal imaging scanning standpoint of view, so this is important. This area is very, very important. Now we see quickly. So these are the 4 thermal images. Which one is febrile and which one is non-febrile? The first image, non-febrile, febrile, non-febrile, and febrile. You can see the thermal patterns. Okay. And if you have to see and identify how the thermal pattern in case of normal person look like and febrile person look like, you can see and make out immediately the difference with this thermal profile. This is the febrile person's image. Yeah. Now I would request Shivani to run the poll question. Shivani?
We have the results
Yes.
here with us. 97% of the audience has voted for yes, and 3% have selected no.
Thank you. Thank you, Shivani. And it's great to know from the audience. And thank you for answering this poll question and sharing your opinion. And most of us, almost 97% people are saying that yes, thermal scanning is important and it can be used as a safety tool to monitor the febrile persons. Now, how we will see using test model 890 and model 872. Yeah, hope my screen is visible.
Yes.
So this is how thank you. Thermal imager will give a preliminary fever information with non-contact and non-invasive method, as we have seen. And we use at various places by various methods and locations. This is how at the airports people are monitoring along with the metal detector by hand or with semi-stationary applications. Yes. Now I'm going to tell you, before you do the measurements, it is very, very important to understand the protocol. So whenever you do a thermal scanning for a person, face should be uncovered completely, no mask, no glasses, no hair on the forehead, and no head covers and caps. So why no glasses? As I told you when I showed you some slides, and on that particular I have requested to run that poll about this Chinese equipments. I'm going to explain you why no glasses and what is the science and what is the why the measurement affects because of that. And from camera standpoint of view, the emissivity has to be 0.98. The distance should be between 8 to 10 feet from camera and to the person. And the location should be, there should not be a sunlight directly on the camera or on the face of a person. No reflections. Temperature should be between 24 to 27. And humidity should be less than 50%, 10 to 50%. Generally, this scanning is recommended to do indoor. Okay, to avoid false negatives, which we have seen, what is false positive and negative, and how it can become dangerous. No air conditioner or grill directly facing onto the thermal imager or on a person. Then degree Fahrenheit tolerance that can be set in the camera. It's a parameter in the camera. I'm going to explain how it works. Height should be adjusted considering the lowest person height. And if suppose the tallest person comes, he has to just bend down. Okay, so that is how the camera and tripod height is adjusted. And the temperature set point can be initially set for 98.5 degree Fahrenheit, including the tolerance. And it can also be consulted with your local health consultant, professionals and doctors. as to what set point you have to keep. Yes. Now, why I said no glasses, and we have seen some misconceptions in our in the beginning of the presentation. Now, for to substantiate that, we have taken two images, one with glass and one without glass. Now, if you can see here with spectacle, the temperature reading goes over here, the highest temperature within this particular red rectangle. And here you can see it is exactly going into the tear duct where we monitor, where we have seen that the core, the temperature of a human being, which is near to core body temperature. So why spectacle is not recommended? So here you are not going to get a core body temperature. In this case, you are going to get a core body temperature near to core body temperatures. So this is the reason spectacles are not at all recommended. So, and we have seen that hype and misconception. Many of the people, they show that even though people are wearing spectacle, hat and mask, still you get the body temperature. No, it is as per the infrared science, infrared theory, you need to expose your tear duct to get the temperature which is near to the core body temperature to decide whether the person has to be isolated for further investigations. Now we use Testo 890 as a solution for scanning of the people. So here the IR detector size is 640-480, 40 millikelvin thermal sensitivity. As I told you, it is very, very important parameter for fever detection. That is equivalent to 0.04 degrees C. We have seen what is thermal sensitivity. And then you can also have the options like fully radiometric video capturing and sequence capturing with this. So we will see now how we do the measurements and how this technology works with Testo 890. So Testo 890, there is a fever detection mode. So you can go into the fever detection mode. So here, what happens in fever detection, as we have seen, we are checking the relative body temperatures, escalated body temperatures, okay? And then fever detection cannot measure absolute body temperature of human being that we have seen. Now we directly go, we have options like you can use the camera as handy for checking the temperatures when you are mobile, when you are checking in the transportation vehicles, in the rails, and metros and local trains and passenger trains. And you can also use at the airport, as factories, in the lobbies, in the reception, in the factories where number of people, hundred and thousands people are coming daily in. So here you can mount the camera and ask people to come in the channelized way and see the camera lens and get the temperature detected in the tear duct. And this camera can be connected to the HDMI to show on a larger screen about that person's whole image like this. So you can see here, once you start the camera, so this is how you are going to get the thermal image. And once you go into the assist menu under fever detection, the moment you go into the fever detection, the screen will look like this. Okay. And now how exactly it functions, that we will see. Now, as I told you, there are two modes. You can operate in automatic mode and manual mode. Manual mode is generally used in when you want to check in the trains, in buses, metros. So you can use the manual mode. And when you are at workplace, you are at airports, you can use as a stationary mode in automatic. Now, how automatic mode works, how the manual mode works. So you have to scale the scale manually as well as automatically. Once you put it in automatic mode, the scale will be adjusted automatically, considering the background temperature and the object temperature. Emissivity we have seen, reflected temperature. Generally, the reflected temperature is set at 20 degrees C or 68 degree Fahrenheit. So then we have to determine the alarm value. So initially you have to set a temperature, average human body temperature, and then add an offset or a tolerance of say 1 plus 1 degree Fahrenheit or something like that. You can set in the menu and set manually or automatically fever detection. Whether you have to go in the mobile applications, set manually. If you want to go for stationary applications, you set it in automatic mode. So this is generally happens in both the mode. Yeah. Now, once you do this preliminary settings, there will be a screen look like this, red rectangle. So initially when the person is coming and looking into the camera lens, there will be a yellow mark, and within that yellow there is a question mark. So that is the sign which will appear, and that means the camera is searching for a person, searching for a face. Generally we have to see the face, and so camera automatically recognize the face. Once it searches, when the yellow box becoming stationary, yellow round is stationary, and the question mark goes, that means camera has found out the person. And when it turns to green, the person is not having fever risk, and if it turns to red like this, then the person is having the fever risk. So how it happens, how this technology works, that I would like to explain you. So this is the yellow, green and red, and once the person is detected with red, the camera has an acoustic alarm. And also, in addition to the visual alarm means that particular portion becomes that activity, know that somebody is having fever, and immediately that person can be stopped there from going inside, and that for that person can be taken into the isolation area, and further medical investigations can be carried out. And you can save that image of that particular person in the camera by capturing the image of a person with febrile values. Yes. Now, how it functions? It's a excellent technology that we are providing to get the accurate temperature. The camera monitors 15 healthy people, and then after each and every measurement, that is number one, person number two, it it calculates, camera automatically calculates the average value, and then it adds that tolerance, and the baseline is set. So that escalated body temperature, that will be declared as a febrile person. So this is how this calculations are happening in the camera, and the baseline is set, and the persons are declared whether they are in green zone or red zone for the further actions. So acoustic alarm, and another is the HDMI output we spoke about. So the camera can be connected to the HDMI output, where the person administrating can see that what is the indication, whether it is green or red, and what is the temperature. So camera also monitors the ambient temperature with the internal sensor. So this is typically a factory scenario if you see. So there are factory and warehouses, maybe you can see the camera where it can be mounted at the entry. So the cameras can be mounted at the entrance, okay? And you can start the screening of a person. So typically you can use the lobby available over here inside. So generally I told you the indoor measurements are preferred. Another aspect is the room temperature and humidity that we have discussed, and reflective background also you should avoid, and there should not be a draft or strong lights. So these are the certain protocols, and you have to allow the instrument to be acclimatized and person to be acclimatized for 10 to 15 minutes to do the accurate measurements, and strategically you can decide the location accordingly. So typically this is how the arrangement is: the person, the camera, and your laptop or a TV screen, and you should have a low reflective background. So there should not be a glass that which is highly reflective. So you should have a low reflective background, or maybe you can use the gray wallpaper or gray cloth. Okay. So this is how the setup should be to get the accurate temperatures. So you can make a channelized arrangement. The people can come into the channel and see into the camera lens. So this can be done internally by marking on the floor the tape. So you can just paste a tape and make the channels, or you can use the channels like you have seen on the airports. So this is how the camera is mounted on the tripod. So one can see this in the screen as well as on the larger screens, TV screen, which can be connected. So this is how we are demonstrating. The person is coming from the metal detector, and this is another method to mount the camera. And person administrating this need not have to go close, so he can, from a sufficient distance, he can see whether the person is having fewer risk or he is not having fewer risk. So immediately he can take the action. So this is one of the example at Escape Bearings in Pune. The securities are administrating the activities. The camera is mounted somewhere here in the near to the metal detector, and persons are coming from outside. And here is the area, indoor area. So at the airport, you can use stationary solution as well as handy. So these are some examples where we have supplied our cameras. So where the portable cameras can also be mounted on the tripod, and you can also just do the mobile measurements at the entrance. So this is Testo model 872 and model 882. So this is how the model 882 can be mounted on a tripod. And you can see in this particular model the visual image, the real image, as well as the thermal image of a person. So this is about the model 882. There are certain examples for channelized mechanism. As I told you, on the airport, you can do such things and ask people to come in at us in a channelized way. So mobile measurements. There are measurements carried out at various checkposts and borders. So this is one of the border, Indo-Nepal border, where we have supplied the camera for mobile measurements. When we talk about Testo 872, we have very good features like this camera can be connected via mobile thermography app, and one can hold the mobile or iPad, and from a distance you can monitor the person and his or her temperatures. This camera also can be mounted on a tripod. And if you need a complete video recording, then a Power Mirror app you can use, as you have seen in the video. So this is Testo model 872 320 into 240 pixel camera. We also have another cheaper solution, lower priced camera, model 868, which is 160 120 pixel camera. I have shown you that image also, 160 120, how it looks like. Then model 882, this also we are aggressively promoting, and we have been supplying in government organizations. We already supplied in Uttar Pradesh state government medical department. Yeah, one of the solution we have is we can offer the infrared windows and infrared views. You can see here, this is the infrared window, and this is the isolation film, isolation barrier, and you can mount this isolation barrier in the reception desk so that you can avoid the risk of coming in contact, and person can be just beyond this safety barrier, and you can just mount the camera on the other side, and receptionist or the person administrating this activity can see his or her temperatures. So this also is the solution we can provide you. So we have seen this, so I'm going to skip this slide. Yeah, we can also give a solution on robotics. So there are companies we have been associated with Energy Guru, where the camera can be mounted on a rover-like device or a robot, and you can just hold the mobile in your hand and you can see the temperatures. This will keep on moving. So that also solution also can be given. So we see the applications now: airports, arrival and departure terminals, IT industries, sports complex, railway stations, big hospitals, concerts, critical infrastructure facilities like the defense, DRDOs and ARDE applications, workplaces, that is all workplaces, government as well as the corporate industries, corporate offices, schools, government buildings, then animal husbandry and pharma industries. So these are few applications which I just wanted to share with you for Testo 890 and Testo 872 model. And just to share with you our important customers, Google India, where we have supplied our high-end model 890 thermovision camera, and they have mounted in their reception lobby. So Infosys India, Samsung India, these are some few examples, SKF India, and we have been also supplying to AIMS, NIMHANS, and SGPGI. These are the three important organizations, medical research organizations, where our cameras are used for medical research applications. Uttar Pradesh State Government, Indian Railways, and Indian Navy. These are some few examples to share with you. As I told you, we have Enable accredited lab where we have black bodies to calibrate the thermal imagers. So this is the example where we have calibrated our model 872, and you can see the black body temperature 35.2. We have intentionally kept the black body temperature near to the human being eye temperature, which is near to core body temperature, and you can see the thermal profile. So exactly this thermal profile and this thermal profile is matching. So whatever black body we have set the temperature as 35, and you are getting actually 35.2, just 0.2 difference. And here you can see the actual temperatures on a person in the same field of view. So the cameras are excellent from measurement standpoint. And this is how, I mean, this is the Enable accreditation certificate, and we have the scope defined for infrared instruments and thermovision camera. So that is all about this today's topic. Now I request you to share your feedback, and I request Shivani, I think we have to launch this poll question now, the remaining poll question. Shivani?
Yeah, we're just launching the poll.
Yeah, thank you.
Please show the result.
Yes, please.
So 99% of the people found this webinar informative and useful.
Yeah, thank you, Shivani, and thanks the participants to give your valuable feedback via this poll question. So I'm very much thankful, and now we will take few questions, and if we are not able to cover all the questions, we will definitely answer and respond to all the questions via email. You can also write to me. This is my email ID and mobile number. If you have any questions, you're most welcome. Sione, can you switch back to the presentation, please?
Yeah, we have the other poll running. Would you consider implementing thermal scanning in your organization? Request all participants to choose the option. So 86% have said yes, that they would like to consider implementing thermal scanning in their organizations.
Yeah, thank you. Thank you, Shivani, and thank you all these participants to give this valuable feedback, and we will certainly take care about your questions, queries, and your requirements. So you can write to me on my email ID, which is appearing on your screen, and mobile number. You can, if you want, if you have any quick questions, or if you are stuck up somewhere on this subject, you can call me. I will help you and address try to address all your questions and all your queries. So
we would like to thank Testo India and Mr. Yelegaonkar for this very informative and interactive session. We would also like to thank all the attendees for their participation. All the questions will be replied to by email by Testo India very shortly. Thank you very much for your participation.
Thank you all.